Four is graphs of functions. Graphs of functions. So you're going to need your graphing calculator. Okay, graphs of functions.
I got one like last week.
The graph of a function f is the collection of ordered pairs x and f of x, the output of x. The domain is your function, and as you study this section, you have to start bringing into reminiscence geometry interpretations for this. Okay, so finding the domain and range of a function. Once again, we're going to talk about finding domains and ranges of a function. If I have a function that looks like this. This is -1, -5, and then it goes through here, and it's 2, 4, and the third point is 4, 0. If I have a graph that looks like that, okay, if I want to figure out the domain and the range of this function, I've got to set up a few things, or I've got to take a look at a few things, okay? Let's talk about finding the domain. Domain is what again? What is my domain? Tell me. Yes, how far something travels on the x-axis. So what would be my domain in this case? -1 to 4. -1 to 4, okay? So my domain is -1 to 4. Yeah, okay. If I have it written this way, where this part here is open and this part here is closed, okay, then I have to know how to write that correctly in interval notation for -1, 4. So -1, because it's a closed circle, has a bracket with it. If there is an open circle, that means I have a parenthesis with it. So my domain in interval notation is bracket -1, 4 parentheses. So on your graphs tonight, you're going to have to take a look at that. Does it pass through that point? Does it end at that point? So it's going to tell me if it's bracket or parentheses. Okay. So that's finding the domain. The function values. Let's say that they say, what are the function values when f is -1 and f is 2? I want to know the function values. Okay? And they give us an equation that says y equals the function of f of x. Okay, so what is my function values when I input a -1 and when I input a 2? How do you figure out where your function values are in that case? What is your function value at -1? You should be able to look at the graph and read this. It's what? -5. So my function value at -1 is -5. When I input 1 into my function, I get -5 out. What is my function value at 2? 4. Okay, it's 4. When I input 2 into this equation, I get a 4 out. Okay, and that's also prevalent on the graph. So we're going to have to be able to look at graphs and decipher what is going on. The last thing I need to know is, what is my range? What is your range on this? Range tells me what? How far on the y-axis. So what is the low point? What is the high point of your graph for a range? -5 and 4. Is it parentheses or brackets? It is brackets. -5, 4. Because both of these are just closed circle dots. So -5, 4. So you have discovered function values, you have discovered domain and range. Okay. Does anyone remember what the vertical line test does? What is the vertical line test?
If it goes through the point twice, it's not a function.
Good. So yes, if I draw a line vertically through any graph and it goes through it twice, it's not a function. You're going to have to apply the vertical line test tonight on stuff.
Oh God.
Okay, so this one here is a function, because if I draw a line anywhere through here, it only touches that graph once. So that is a function, okay? So you're going to have to be able to apply vertical line testing today. The other thing we need to talk about is increasing and decreasing functions, okay? Let's say you have a graph that looks something like this, and you want to identify all the increasing and decreasing functions. So you have a point at 1, 0, 2, 0, 4, 4, okay, and -1 and -2, 4. So here is a graph that you have, okay? They want to know if this graph has constants, if it has decreases and increases. What do you think? Yes, where? What does this segment right here appear to be? A decrease, okay? So this is a decrease. What would this segment be? A constant, that's what we call it. And then this would be a increase.
Got it.
Okay. So you are going to have to be able to identify where graphs are decreasing, constant, and increasing. But we also have to write those in function notation. Okay. So if I want to write these in function notation, this is also where you might have more than one equation. Like yesterday when we did piecewise functions, okay? This is where I have piecewise functions. This here is its own function. This here is a separate function. And this one is a third function. So in this, I have 3 piecewise functions, which makes my whole picture, because it's not just flowing, okay? If I had a graph that was curving, okay, that would be one equation. But because this has starting and stopping points, that is not one equation. Does that make sense? Okay, so you're going to have to be able to tell that. Can you tell the relative minima and maxima on things? Can you look at a graph and tell me the high and low points? Okay, I hope so. On your graphing calculator, when you graph something in there, if you want to tell me the high and low points exactly to the specific number, you press the trace feature and you use your over key until you get to the high point and it will tell you what it is, and then until you get to the low point and it will tell you what it is. Okay, it makes it very simple for you. So graph this in your graphing calculator for me. Let's do f of x equals x cubed plus x. Well, let's do equals negative x cubed plus x, okay? Graph that in your calculator. You said x cubed is stupid?
No, I said it's x cubed. That's
Negative x cubed and then plus x. And if you have it in the standard viewing window, you should get a graph.
What are you?
And it should look something like this, where it comes like this, yes?
Yeah.
Okay. Okay, now, if I want to identify the relative minimum and maximum on this, where do you think the relative minimum is going to be? Yes, this first dip right here. Where's the maximum? Right here on this dip. So what you're going to do is you're going to press that trace feature, okay? And it's going to start you at 0, 0, at least mine does, and you're going to go over to where the minimum is. What does the minimum appear to be with the trace feature? What does it appear to be?
You mean like points?
Yes. That's your minimum?
7.5.
Mine, I stuck on a line.
That's why you gotta like move it, you gotta trace.
No.
9.4.
Your minimum is right there in the curve, and your maximum is right there in the curve.
Gotcha.
Okay, your minimum and maximums happen at curves, at turning points. Okay, so your minimum is here on your turning point, your maximum is here on your turning point.
2004.
There's no way it's 2004. Good, negative 0.6. And what's the y part on that one, Lindsay? Negative 0.4 if you round it. So this is my minimum. What is your maximum appear to be? Go over to the top up there, as close as we can get it. 0.6, mine says 0.8, and then like 0.2, right?
Yeah.
Okay, so your minimum and maximum are found by using your trace feature.
This is incredible.
What?
All this math.
That you don't have to do
Yes.
it. That's found using your trace feature, okay? This is what we're going to work on tonight because tomorrow we will talk about, or Thursday we will talk about piecewise functions, even and odd functions.
That's why I said.
Crazy, that's true.
Yes.
I know when everyone says cube, I think